So to show you the back end of this, I'm going to start off by showing you the database tables on where these products are loaded. And to refresh you really quick, remember that each product has a unique name. It has a unique link that's in this view details thing. It looks like here you can also click. It has the lowest price. Each product has its own lowest price. Each product has an image. Okay, so here are the printouts of the a tabular display of the database tables where these products are stored. And you will see here that we have all the info you've seen there. Most of it. We have the unique product name for each product name. You remember from the last videos, if you watch those, we get the 3-atom fresh greenery. You just recognize all these products. Each product has an image. Okay, so there's the image file for the product. Then here's the link. Okay, this is the extension, if you want to call it that, to go to the products page. And so here, if I click on this fresh weddings, that's not it. Fresh weddings wreaths. See here, that's the that right there. Takes you to the page. We got these different sizes. So go back here, I'll show you. See that same thing. So there's the URI, and then each product has a description, but we don't see the description on the storefront page, although we do see it on this page. And we have fresh, spring or summer seasonal mix. See here. I haven't given you all the tables either. I'm just giving you a few of them here. I don't want to overwhelm you. There's some other tables involved here too, but you'll see here there's the same text right here. This is all loaded from the database. And you'll notice on the storefront page, the prices are missing. Or the prices are missing on this products table that you don't see the unique lowest price there. And that is because that is on the product sizes table. Here's the product sizes table. If you go back, let me go back here real quick. Notice that each product has its own unique product ID. And again, if you've got a store on Etsy or a store on some shop online, ultimately on their back end, it's going to be something like this, very similar to what I'm showing you here. It's what you're going to have on the back end. That you go and add a new product, and you add a name, and you add an image, you add a price, and all this. It's going to go to a database table like this, something like this, with a unique product ID. The name will be stored. The image file name will be stored. They'll have, sometimes they call this a slug that goes in the URL bar to locate that product. You'll have the sizes and so forth. Something very, very similar to this, and this is a really well designed set of database tables that I've got here. I've got the database tables pretty much optimized to the extent that they can be. These are properly, they call this normalization. The way that I've designed these tables to have all of the data on discrete tables. I don't have a big mega table with all of this. I don't have it with all of this and all of this. I have it on separate tables. And that is what's ideal for being able to manipulate the data and do analysis and stuff. But you'll see the product has a unique product ID. And so on this products table, you'll see that it's connected to the products sizes table by the products ID. So you saw the fresh wedding wreaths, that was product ID 1. I had two sizes, and there are the two sizes. There is the description. And I've got the length, width, height, and weight, and that's for the shipping feature to implement the packing them into boxes for them to minimize the shipping cost. We use the dimensions to pack the items into boxes to figure out what's the optimal box structure, which the algorithm I programmed is ultimately extremely simple. I won't get into that, but we pack the items in the boxes using the length, width, and height. Then we use the weight to aid in calculating shipping. Sometimes the weight comes in, sometimes the weight does not come in. it depends on if the dimensional weight of the box as calculated by the carrier. So you got UPS, UPS, USPS have their own dimensional weight calculations, and if the dimensional weight based on the size of the box exceeds the weight of all the products in the box, and then the product weight doesn't matter. But if the product weight is bigger than the dimensional weight, then you get charged by product weight. If I recall, that's how it goes. And so this is used. There's the box packing, and there's the pricing the boxes per the carrier, what the carrier is going to charge you. And so this all goes into the shipping calculation. And you'll see here we got all these product IDs all the way down to product ID 25. So we get the same product IDs here. And again, I omitted some tables. I've omitted the bullet items table that has the bullet items for the products that you see when you go here. The bullet items for the products. I've omitted that table, and I've also got tables that manage the categorization. Okay, these products are in categories. I've got those that manage the categorization that are involved. But I don't want you to overwhelm you. I'm trying to give you an intuitive understanding. And this right here, what I'm showing you, will be plenty good enough for that. This is the data that you're seeing on the products page that I just showed you with the wreaths, the garlands, etc. And in terms of the lowest price, that comes from this. Okay, each product, you have products, individual products. Each product may have will have one or more sizes. Okay, most of them come in more than one size. Some come in only one size. But the abstract product, the generic product, just the product itself, doesn't exist outside of having a size, and so the sizes are what is priced. And so what happens on the programming end is this is an output of database tables. This application that I've developed, that you're seeing here on the back end, will pull all the data from this table, pull all 25 of these products. It'll pull all of the data here and match them up. Then it will pull the data from the categories table to sort everything into categories. But forget that. We'll consider the categorization part magic and focus on the products on display. It takes all this data. It connects the products by the product ID to know the different sizes, and it takes all of the prices for each product, and it picks the lowest one. Okay, so some of these products you see here, I believe this is a boxwood wreath here on product ID 4. Product ID 4 has got 4 sizes, and so it'll go through all 4 of these and pick the lowest price to display on the from price. Okay, so that's where that unique price comes from. It doesn't come from the products table. It comes from the product sizes table. That the first step is the programming is going to pull all of the data off of this. Then it's going to have to go through and organize it and sort it around and count everything by category, and it's also going to have to pick the lowest price for each product to display on this first page. Now, when I very first made this store, I had the lowest price on this table right here. I had some kind of price column, and that made it such that all I had to do was pull the data off of this table right here to get the to get all that I need to display here. That I could just pull the lowest price and directly off of this table and load it here. Now I changed that. Trying to remember when. I can't remember. It was pretty early on. Right around the time I put it live, or maybe a little after. It's a screwy process, because what happens is when you have the lowest price on this table, you have a column, because again, this gets put in the database. and again, building this site, I was kind of roughing it in a lot of ways. That it was a brutal process. I spent God knows how many hundreds of hours building this thing. As a monster project, building an e-commerce store, hand coded from scratch, full featured, shopping carts, payment processing, the whole thing. I mean, it's a freaking beast, and I had to do what I could do. And so what I was doing is that they would send me their product listing, and I would enter them directly into the database. I would manually enter the data into my database application. Manually. Now, what I was going to do, and what would happen on this redesign store, is I would have them a UI where they can go and just put their own products in without sending me a listing page. And again, like you got Etsy, you got an Etsy store or whatever store. This is what happens. You go to UI, you've got to add a product, and you enter all the details. When you click send to add that product, you click add products. It goes to a database table like this, and the data is loaded onto a table like this. I'm going to go back. It gets to be a screwy process, because then I've got to add the same stuff into two tables, and there can be a mismatch. Okay, potentially. Like say I've got these four box wreaths here, and say I accidentally forgets to update. The lowest price is $30, and say that we knock everything down by $5 or something, and so now I've got $25, $37, $50, $70 is going to be our product prices there. But I forget to update it on this table. Well, then I'm going to have mismatched info. This is one of the things you do when you design a database. You don't want to have double data anywhere. You want everything to be entered once. And so here, I only have the price for everything I'm entered once. And it all comes from this table, and the algorithm picks the smallest price available for each product. So in other words, when I update this table, automatically the smallest price on this table right here on this display is going to be updated. It's a really efficient way to do things. And so what happens on the end-to-end process, the customer goes to the products page that you just saw. They click on a product, they select a price, they add it to the cart, they enter their zip code, the shipping algorithm runs, calculates the shipping price. Then once they've entered their zip code, as they enter products, the shipping total updates. The products will be reboxed. Say that they put two of these, and they got two of these, and then they order a bunch of other stuff, and say these two right here were originally, they were in one box. Or say they got one of these 20-inch wedding wreaths, fresh wedding wreaths. They got a 20-inch, goes in one box. And then now they order a bunch of other stuff. Then we reconfigure the boxes. That we put. We might put this 20-inch and this and this and this in one big box to save on shipping. And it was a really it all worked the same ultimately on the back end, other than being a procedural code. It was a really nice application. I was really something I was really proud of. That not many people can do it at all, much less people just started out from nothing, building an e-commerce store. I never written a lot of programming, and then once they're ready to go to the checkout, they go to the checkout. They'll have a page to review their stuff. They put their shipping address in, and then they go to the payment page, which was an externally hosted payment page that would either be done through the payment providers, like it was called Authorize.net, and so they have a payment form that's kind of like PayPal, where you leave the site totally, and then there's a payment form that's loaded onto your website. Is what it looks like, but you're actually directly on the payment processor's web server that just has the appearance of being on your website. It's loaded to something called an iframe. And the purpose for that is it is extremely a security-intensive thing to process a credit card on your web server. And so if you're a small business, you don't want to deal with it. Okay, you don't want to have thousands of dollars a year to implement security protocol for you to process cards on your website. So what you do is you have all the payments stuff outsourced to a third-party payments provider, like Authorize.net, PayPal, whoever it is. That's got they got the maximum security. That they're beefed up, and you don't have to worry about a security protocol because no credit card data ever touches your servers ever. It never touches anything that you own. It never touches your web application at all. And so that was what would happen is on the first version of this, they were going to a totally external payment page. Okay, they would be redirected to a new page, and they would enter their payment details. And of course, when they go to that page to pay, because they click go here to pay, they're leaving my client's websites to pay. Now the thing is their shopping cart is on my client's website. Okay, that what happens is there's an API call made when they click this button to pay, because that sends them to Authorize.net. As it's sending them to Authorize.net, it sends a bunch of data about the order, like the total of the order, the merchant name, and stuff like that. And that's how Authorize.net on their external payment page knows what to charge them, knows what merchant it's tied to, and stuff like that. We send like generic transaction data like that about the price and stuff like that. And but we have no access to Authorize.net's servers. There's nothing we can do there. That's the whole point of having an external payment page. And so what happens is the person pays on Authorize.net's page. Then they are redirected, once they pay, back to our page to a thank you page, and thank you for your order. But there can be something where the person, before it redirects them, they close their browser window. And so what we have there is we have somebody who's paid for an order. They got their cart, they've paid for it, so now it's not a shopping cart, it's a paid order full of items, and we don't know that they've paid. We got to have some way to know who pays and who didn't, and we've got to have some way of keeping track of our orders. So what happens is when they click that payment page to go to Authorize.net's external hosted payment page, at the same time that this API call is made to send Authorize.net their data to redirect the clients to the external payment page, the person's shopping cart is entered as a paid, or is entered as an order, like a completed, or it's entered as an order. Okay, so it's no longer a cart; it's an order on the orders table. So when my client goes to their admin page, they've got an order on the orders table, and we set up a system where Authorize.net's web servers would ping an endpoint on my clients. When I have my client's application, would ping an endpoint on their on our web server to tell us if this transaction was paid. That we would have an invoice number tied to every order. So what happens is they click to go pay, and we have no idea if they're really going to pay, if they're going to click the back button or whatever. But we assume this is an order. Okay, so it goes into the orders table, but we're not going to send people stuff that they didn't pay for, and so it goes into the orders table. Tied to an invoice number. Authorize.net, when we do the API call to redirect them to the page, that's another thing we send Authorize.net. We send them the invoice number, and when Authorize.net pings our web servers with the transaction results, we tie that invoice number to the order on the orders table, and we mark that paid, and that's how we know what stuff to ship. That when you have a totally externally hosted payment page, you get a whole lot of benefits in terms of not having to run a really, really intensive security protocol. Okay, that when you just got a web server up to load products into a shopping cart, your protocol requirements are pretty darn minimal. Okay, when you start to get to the point that you're processing credit card data on your server, I mean it's a brutal regimen. So you save yourself from all of that, but it does add some kinks in the process. One being that you have to do a little bit of gymnastics to determine which orders have paid and which have not, because the payment takes place on a website separate from yours. Now, on this version of the store, I was implementing, and I had another client I was working on his website before I got disabled. Had the same thing, and I had his website just about done when I got disabled. I was ready to go out the door. And this poor guy, and he was happy about it too, because I'd done a lot for him. Had him a real nice package set up, but I'd been way over deadline with him, and I wasn't able to get his store. I was right there, and I had like 99% done, but I had an iframe set up where you're still on the external payment provider's web server. But you're viewing it through an iframe on this, like a website like this, so to the user, it's a much smoother experience. They don't have to leave to go to external websites. It feels to them just like they're on your own, the same website they've been on, and it makes it a little bit easier to track who's paid because you set up through the iframe, you set up a communicator that will relay the transaction results back to you. When the person clicks to pay. And so what I would do there is I would have a two component system where I would take the message I got from the iframe communicator to update the orders, and then as a backup, I would have the have a webhook sent to my servers. That's what they call it when authorize.net pings your server with information about a transaction. I'll have a webhook come around as a backup, and I would be able to capture all the transactions.